today's resources on the Schoology, but I will upload them today and then upload the video. If you missed school, please make sure you're taking advantage of those resources. Please reach out to any friends of you any friends of yours that you know have been regularly absent. Like anyone friends with Anna Lorenzo? Can you talk with her? I don't know if it's COVID or anything like that. I haven't heard from her, but she's been absent all 3 days this week. 4 days total, and I'm worried about her. Denasia Pruitt, I haven't heard anything from her. And she's been absent all this week. I'm assuming COVID, but I don't know. Kenyon Sewell, I haven't even seen yet.
I heard she was in Mexico with his sister.
I mean, he is, but I think he said he was supposed to graduate early. So like he did all his classes last semester. I don't know how true that is.
I was saying he has to have taken Algebra 2 to graduate. You literally have to. Okay.
I think he's already taken it though. I think that's what he was talking about.
Okay. Reach out. If you know them, please just reach out to them. I'm concerned about them. Just because I want us to learn well, and it's hard to learn well when we missed 4 days out of the 7 we've been here and stuff like that. All right. Let's go over the bell ringer. As always, right? I need you to do the bell ringers quickly and efficiently. I definitely took way too long getting started, but in the beginning of the semester, I will have to do that just so that we establish the classroom culture that we want.
Mr. Kenny,
Yes, ma'am.
can I have another Desmond sheet? I don't know what I want out of his head with.
Lord.
I'm so serious.
I'll come by and look for it later.
I found it now.
Okay. Anthony, I need you to put up the math literacy stuff. You can work on it during enrichment or something. Guys, I need y'all focused on the bell ringers right now so that we can make sure we're learning from mistakes and things like that. So, really quickly, because I already heard this come up, is the multiplicative inverse and the additive inverse the same thing as the inverse of inverse of addition or the inverse of multiplication? No. They're heavily related, right? But the inverse of addition would be subtraction. I'm just not the inverse, the additive inverse, right? The inverse of addition would be subtraction, right? The inverse of multiplication would be division. And they're tied into that, right? But we want to notice what is the additive inverse. So majority of us said 2/5. A couple of other ideas in here. Really quickly, I'll say this. What is 0? That is important.
That's the additive identity.
Additive identity, right? So remember, when I combine the additive inverses, I'm creating the number 0, which is important for solving equations. What is -5/2? That's not the additive inverse.
That's the multiple inverse.
Multiplicative inverse. Remember, what's the other name for the multiplicative inverse? The reciprocal. There we go, right? And we talked about that pretty heavily yesterday. But the additive inverse is also known as the opposite. Hopefully, for those of us who missed that detail, do we understand what the additive is?
2/5?
Work on that language just a little bit. Not 2/5. 2/5, or what's the other way to say it?
2 divided by 5.
2 divided by 5, right? I know it sounds crazy, but again, this is important for understanding multiplicative inverses because, and I don't even remember who asked me earlier, but they asked the question, how do I make a fraction on the calculator? Well, there are two ways. Look at the division symbol, and what does it have in gray? A fraction, right? So you'd have to hit control and then the division symbol. But the reason why that is there is what does that fraction bar indicate? Division, right? So you don't have to put a fraction into the calculator. If you use the division symbol, it understands that you have a fraction because all that fraction bar is division. All right? Multiplicative inverse. About the same number of us got the multiplicative inverse. 2 times 5 is 10 is my guess as to where that came from, but I do want you to notice, again, what do we do to get the multiplicative inverse? The numerator and denominator flip or switch, right? And again, we have an important number here. 1, what is that called?
That's the multiple identity.
Multiplicative identity. And remember, the reason why we call it an identity is because it doesn't change the identity of that number, right? If I take 7 and I add 0 to it, what do I get?
7.
7. That's the additive identity. If I do 7 times 1, I get 7. That's the multiplicative identity. Those things don't change the identity of the number when we add or multiply. That's why they're called those identities. This is the one I was most curious to see. So x equals 7, or 7 is the most common response that we have here. But I'll go ahead and tell you,
I got it right.
only 2 students got it completely right.
I know what it is.
What is it?
7 is negative 7.
7 and negative 7.
And me.
Why?
Oh, so you up there with me.
And me.
Because you do the square root.
And me.
Okay, so it is important to notice, right, we take the square root of both sides, because that's the inverse of a square, but put in the square root of 49 in your calculator. What do you get?
7.
7. Do you get the negative 7?
Uh-uh.
So why is it 7 and negative 7? By the way, I need you all to do this. When I say put it into your calculator, everybody pick up your calculator, get used to plugging that stuff into the calculator. If you don't know the square root of 49 off the top of your head, calculators are great for calculations.
What's wrong with that?
That's a great question. Where is the square root?
Square, or look on the left side of 4.
Look at the left side of 4. You see where it says x squared?
Oh,
And in gray above it, it's got that square root symbol.
49.
Square root of 49 is 7. It doesn't tell you negative 7, does it?
No.
So why is negative 7 also a solution?
Because negative times a negative equals positive.
Remember, what is a solution? So I'm going to come back to that idea in a second. But when I say solution, what am I asking?
Negative 7 times negative 7.
Kind of. When I just say solution in general, though.
Scientific, method, math method.
The
Math
mathematical statement.
It deals with a mathematical statement, but a solution has to do what to the mathematical statement?
The value.
It has
is
to
a
be
value.
equal.
It has to make the mathematical statement
True.
true. And be careful, don't just say it. Be clear with your language, right? It has to make the mathematical statement true. And so yes, does 7 make this statement true? Yes. But does negative 7 also make that true?
Yes.
Because a negative times a negative is a positive. So remember, that calculator is not going to tell you the negative 7. When you take that square root, you have to remember it's going to be positive and negative. We good on that detail?
Yeah.
It'll come up throughout the semester, so I want to build that foundation in now. Any questions on bell ringers? Going once? Going twice? Sold. Moving on. All right. And I also didn't see any super questioning looks. What's your question?
This sheet,
Mm-hmm.
I don't know where it is. You don't know what?
Just losing your stuff all the time.
Look at your color.
I mean,
That's why.
yeah, I found my paper for your information.
So you can focus.
Yeah.
Okay. Sir. Oh yeah, you missed yesterday as well. Yeah, go to the back counter. It's the sheet in between the blue. It's the middle pile back there. Go to the back counter. It's the middle pile back there.
Just talk about you.
Okay. Thank you.
Yeah.
Shut that mouth.
Okay, so you're Kenyon. Nice to meet you. Does anyone remember what group Kenyon was in?
It's right there, I think.
Was he in group 1? Okay, so Kenyon, you're gonna be up there. I'm gonna bring you a piece of cardstock to make a name card, stuff like that. I got a lot of things to give you, so we'll get. Actually, for now, Kyle, can you grab one of those packs for Kenyon as well? And then we'll get started. I'll give you the other resources you missed. Okay, Kenyon? So, agenda. I always, at least for these first couple of weeks, want to go back to this foundation. All right? The question is, what is math? Gerald, what is math?
Patterns and relationships.
Okay, it's something with patterns and relationships. Jenny, what is math in respect to those patterns and relationships? You don't remember? Come on, we got notes on this. We should have it.
Just, you want me to say it?
The study of patterns and relationships.
Okay, so the study of patterns and relationships. Those of us who can't or don't have it on the tip of our tongue yet, go back to your resources. That 1 to 100 tab should have it written on the back. I'm going to keep reminding you of this. And I'm gonna start calling on people, right, to get everyone involved. You gotta know math is the study of patterns and relationships. So Ayana, what do mathematicians do with those patterns and relationships? What's one of the things they do?
Notice.
There we go, right? So we use our resources. I'm going to keep pointing this out. So often I hear students say, Mr. Kinney, I don't know how to study. Well, you go to your notes. That's why when we did the bell ringers, you know, looking at me like, I don't know what to do. You're blankly staring at the calculator. Hey, get out your notes from yesterday. Right, so mathematicians notice patterns and relationships. Ishmael, what's something else mathematicians do with patterns and relationships? You're blankly staring. Where's your notes? Where did we write it down on? I think it was on the back of the 1 to 100 task. They notice and then they describe patterns and relationships. Caleb, what's the third thing they do? They notice patterns and relationships, they describe patterns and relationships, and then mathematicians, there we go, get our resources out. Look at the back of that 1 to 100 task. Oh, you found it. I'm glad you found it. Thank you, sir. And then they generalize those patterns and relationships, right? So that is what we are doing in class. We have to notice patterns and relationships. We have to describe them and then generalize them. Keep that in mind. We're going to look at the rubric again. And this will probably be our last day of the rubric reminders. Might bring it back every now and then. Apparently I forgot to update this. We're not going to look at the graphic organizer today. We're going to just look at... Do I have the right slide open? No, I don't. That's why it had the wrong thing. We're on day 7 class. I don't know if you knew this. January 13th, not January 12th. I'm shaking my head at myself too, right? Alright. There we go. Lesson 1. Understanding concepts of linear functions, right? We talked about inverses yesterday. And today we're going to get into translating among representations. And then we're going to hopefully get to lesson 2 where we start using the calculators even more powerfully. We already addressed the idea of additive and multiplicative inverses and the identities. Remember, if you were out yesterday, right, because a handful of us were out, where can you go to see the discussions that we had?
The box.
YouTube. It's already posted.
Oh.
Okay, so I've already posted on YouTube. You just search my name, Nathan Kinney, it'll pop up. I didn't have time to do the timestamps before I left school yesterday, but I had them posted with the dates and with titles so that you knew what order the videos went in. Take advantage of your resources. So here's what we got to yesterday. I believe we started on number 3, solving or showing your understanding by explaining what to do to solve this equation. Quick show of hands if you did not finish number 3. Y'all did not quite finish number 3? Y'all did not quite finish it? Oh, because you were with that group. Did the other groups finish?
I did.
I did.
Y'all did? Group? No? So why didn't y'all tell me? Why didn't you tell me that you didn't finish? Y'all, legitimately, I need you to tell me how far we got so that I know whether we need to continue or not. So let's do this. Let's take about, let's say 2 more minutes. Work within your small groups to finish this. Now, please hear me very clearly. Hey, stop and listen. I saw students working yesterday both in this block and in the later block, and we did not follow directions. I need you to do this. Don't just solve this equation like you're used to. You can think about that. But what I'm asking you to do here with number 3 is show your understanding by explaining what you do to solve this equation. Connect your explanation to numbers 1 and number 2 above. If you don't use numbers 1 and 2, it's hard to completely answer this question, right? So use numbers 1 and 2 to help you on number 3. 2 minutes, get to work, and then we will continue on from there.
First step, I use additive inverse to calculate the equation.
That is what you were used to doing, right? Remember, we want to think about additive inverse and multiplicative inverse. Did you just divide by 7 in number 2? No, what did you do?
What is it? Like, what kind of class is it?
It's history, but he makes you write notes yourself. He'll tell you.
Got a 7, and then what's the other number?
It's important something that you write.
Remember I asked you about the
But it's
multiplicative
a
inverse.
lecture class. So how we can get notes and you write it.
What's
Did
on
you
your,
use your
that would be
multiplicative
the
They don't even show
multiplicative.
PowerPoint. They just talk.
Yeah.
And then.
That's all
The
I'm
whole
asking you to
time.
correct that.
And
So
you
you're
find
close.
out
Right?
what
But you still have, oh, there's
What if you remember everything?
Yeah.
I doubt it.
Kylie, do you have your name card?
So he
Yeah,
just
so
sit
you're
there
not
talking to the
flipping it, that's my
whole
only
class.
question.
That's the
Doesn't
she we were
matter.
working on yesterday.
I mean, he
Understanding
showed the
linear
PowerPoint every now and
concepts of
then.
linear functions. Weren't you here
But it
yesterday?
was like, it was after he
Check
finished.
your backpack. If not, let me know. I can give you
Man,
an
I-
But it's too hard, and then plus we got.
Never mind, Mr.
Just
King, I did.
because it was the first day.
You what?
It was a short
I
lecture.
did.
Because it says.
How long?
Oh, you did finish number three? Okay, just about another minute. Let's keep working.
It started at 11:30. But if we
Use
just
the-
stayed longer, it still
We're-
would have went by.
we're going up language
Because
just a
he
little
got
bit.
the
Just
12
cancel
real
it.
quick. And then we started, hit 12 o'clock,
It's a good start though.
quick as hell.
I don't want it.
Why? What you gonna do?
I'm working on the second.
How would I know what you want?
Huh?
You need a diploma and you need some type of certification saying that you know how to do it. So you still gonna have to go to people, at least show them.
Yeah.
Get it.
Yeah, I gotta go to something. Yeah.
Yeah, you already have it done.
And then if you
Well, you do know you can start that now.
Can all combine
But next year,
Yeah.
you come back, go ahead and start doing the wrong, so you can go ahead and take that class.
Thank you, thank you. Quick show of hands if we are not done at least solving this problem now.
And you can have one year.
We all good? Ish, both.
I ain't gonna have
We'll explain some of it together.
I'm gonna do one class next year.
Y'all done? Okay, so let's look at number 3 together. Show your understanding by explaining what you do to solve this equation. Connect your explanation to numbers 1 and number 2 above. And I'm going to rewrite that equation because it's a little small over there. Dawson, what'd you do here?
I subtracted 3
Okay.
from 3 and 45
Can you explain to me why you subtracted 3?
to get a 0.
Okay, so that is going to create a 0. Can anyone explain to us why we knew to subtract 3?
Because it's
To isolate the equation.
I mean, yeah, well, not isolate the equation, to isolate the
7.
Variable.
variable. We're trying to isolate the variable, get the variable on its own, but that's what we're trying to do. That's not why we knew to subtract 3.
because it's the additive inverse.
Close. And that's something I want to talk about really quickly. Is subtracting 3 actually the additive inverse?
Mm-hmm.
With an additive inverse, you need to add. Now, subtraction is the inverse of addition, but I want you to think about the additive inverse. What is the additive inverse of 3?
Negative.
Negative 3. So if I'm actually using what we did in numbers 1 and 2, right, I need to add a...
Negative 3.
I need to add a negative 3. Now, I'm not saying to do that here. I am going to say to follow that in the future one, but I do want you to notice, in order to actually use the additive inverse from number 1, you have to add a negative 3. But when you add a negative, you just end up subtracting. Does that make sense a little bit? And I do want you to notice we are creating that additive inverse here. And so, this is the whole point. What is 7x plus 0? 7x equals 42. Now, I'm going to pause for a second. I'm going to talk about some really important ideas that you need to take notes on because 1, it's part of your graphic organizer, and 2, this is foundational to what we do when solving equations. What is the relationship, or does anyone know what the relationship is between this equation and this equation? Are they different? Are they similar? Are they kind of the same?
It's similar.
They're similar? How so?
Because
Which one do you think is an expression?
The 7x equals, well,
both of them are expressions.
because they got equal signs.
They got an equal sign. Am I saying that 2 expressions are equal?
Mm-hmm.
So is it an equation or is it an expression?
It's an equation.
It's an equation, right? It's got an equal sign, it's an equation, okay? So what do we mean by they're similar? And I would say they're even more than just similar, but what do you mean by they're similar?
The same thing.
They both got the same equal sign. And the number's close? I don't know.
Let me ask you this. What makes this equation true? Will it also make this equation true?
Yeah.
Yes?
Yes.
So this is an important mathematical idea. Even though those two things look different, they're still the same. That means they are equivalent.
Surely, cause we just simplifying.
Kind of. We simplified after here, but that's not why they're equivalent. When we say equivalent, remember what I just said, that means that they look different, but they are still the same, okay? And that's not proper mathematical language, but it's very close. So, in this case, and I'm gonna go ahead and say the equations look different, but are the same.
I got a question.
Yes, ma'am.
Is this the same thing as equivalency?
It deals with equivalency, yes.
Okay.
So, trying to think, see if I'm using the language right here. If I remember correctly, equivalency is a noun, whereas equivalent is an adjective. So like they're the same thing, but one's used as a noun, one's used as an adjective, right? Equivalent equations describing what type of equations they are. Okay, so it ties in very heavily to that. And so it's not just equations that this ties into. Is there another way that I could write 3x plus 2 plus 4?
Yeah. 2
Yeah.
plus 4 plus
3x plus 6?
Yeah.
Those look different right now, don't they?
Yeah.
Did you say no?
I said, mm-hmm.
Oh, okay. So they look different, but are they still telling the same story?
Yeah.
So they are what to each other? Equivalent. You can have equivalent equations, you can have equivalent expressions, you can have equivalent inequalities. And here's the thing, we need them to be equivalent because the whole point is I'm trying to solve this equation. If I create a different equation, am I going to be able to solve this one?
Yes. Wow.
If it looks different and it is different, right? If it's a different equation, am I going to be able to solve this one?
No.
No. So what did I do to create an equivalent equation?
You made the 3 a 0.
So now I'll point this out. That 0 was not to make it equivalent. The 0 was to create that additive identity, so I'm left with just 7x.
You isolated this.
But is that what made this equivalent?
No.
Okay, I'm going to reword this. What you have always said and always heard is whatever you do to one side of the equation, you have to do to the other side of the equation, right?
Equality.
So that's a what?
Equality.
Okay, it's a property of equality. So, to create equivalent equations, use properties of equality. I will say this, and you'll hear me say it throughout basically every unit we ever study. Mathematicians are not original. Literally the words that they say are what the thing is. It is a property of what?
Equality.
Equality, meaning that I am making equivalent equations. If I want them to stay the same, I have to use this property of equality.
I'm not gonna cap. I was thinking equality at the same time, but I didn't think it was that because you just kept going because I was about to say it.
Dang, sorry dude, cutting you off, that's my bad.
You just kept
Okay.
going.
I just kept going too much, I know. So, this is a good thing to note, right? I'm going to create a numerical example, not just an algebraic example, because I feel like we lose some of the understanding when we just do it algebraically, because there's a variable there. If I were to look at 3 plus 4, that equals what?
So,
7, right? Actually, let's do that. Now, if I rewrite this and I do 3 plus 4 minus 5, does that still equal 7?
No.
no.
What do I need to do on the right-hand side to make these two things equal?
Minus 7.
Not minus 7.
5.
Yeah.
I subtracted 5 here, right? So what do I need to do over here?
Subtract.
Subtract 5. What is 3 plus 4 minus 5?
2.
2 equals
2.
2. That's what a property of equality is saying. If I subtract 5 from one side, I got to do it to the other so those things stay the same. And then I'm doing that with my variables to solve that equation.
So what do you write for like step 1?
What do you mean?
It says show your understanding by explaining what you do to solve the equation.
Mm-hmm.
So
And the way I would explain this is, first off, why did I subtract 3? To
To-
create a 0, right? So if you were trying to explain this, right, 1, additive, inverse, to create a 0, and we didn't just subtract 3, I had to do it to both sides to make the equations not equal, equivalent, right? Notice these two things are equal, but that doesn't necessarily mean they're equivalent. Another way, remember the way I have it up there is equivalent is the equations look different but are the same, meaning they are always the same. These two things are not always going to be the same. In fact, what's the only value for x that would make these the same?
6.
6, right? Nothing else will. Equivalent means they look different, but they're always the same. Additive inverse to create a 0, and by the way, does anyone have a guess what property of equality this is called? Mathematicians aren't original. We subtracted by 3 on both sides, so it's called a? No.
I don't know.
What did you just say?
Subtraction.
Subtraction what?
What?
Equality.
Property of equality, right? That's all it is. Mathematicians are not original. We subtracted on both sides, so it's called a subtraction property of equality. Right, so explaining this out, additive inverse to create a 0, and you could even go into that detail, but property of equality to create what? Why are we using a property of equality? Well, we created a 0 with the additive inverse, but why did I use a property of equality? What's the point?
Equal equation.
Not equal, equivalent.
that's the same thing.
No, sir, it's not. I literally just explained this. Remember, equivalent means they look different but are always the same. Remember, Anthony, you just said, what's the only value that makes this equation true?
6.
6. So does that mean that these are always the same or only the same when it's 6?
Only the same when it's 6.
They're only the same when it's 6, so they're not always the same. Equivalent is very different than equal. And I will tell you this is a concept I did not fully start to understand until about 2 years ago. And when I did start to understand it 2 years ago, it transformed my understanding of math and how I was able to solve problems and teach it. And it will help you significantly to understand the term equivalent. Okay.
So equal is like equal. And equivalent is like they don't look the same, but they equal.
But they are the same. They don't look the same, but they are the same.
But they are the same.
Mm-hmm.
Alright.
Mm-hmm.
Well, can they still be equal? Even though they're the same?
Okay, so you said they. What do you mean by they?
Equivalent equation.
So, well, we would just say equivalent equations are equivalent. We wouldn't necessarily say they are equal.
Alright.
Okay? So, I know that's a lot of background, but I will point out, does that give us some good definitions and terms that we can add into our graphic organizer?
Yeah.
Looking really quickly at that graphic organizer, what terms did we just cover?
Equivalency.
I guess it was just equivalency, but we also talked about inverses and identities with that.
And properties of equality.
Oh, and properties of equality, thank you, right? So we have multiple things on that graphic organizer. So don't write out those explanations right now, but you may want to go ahead and note to yourself which lesson should you go back to get notes about those concepts. Right, it's not, I'm not trying to trick you, look at the top, it's called understanding concepts of linear functions, right? The task we're working on right now is the lesson you would want to go to get your notes about these concepts. Now, if you didn't write these concepts down, then you would have to go to YouTube.
So, like, on property of equality,
Yeah,
what should, if
I mean,
you
what's the point of properties of equality? To what? Create equivalent equations.
Okay.
But how else have you talked about properties of equality in the past? Whatever you do to one side,
You
you have to do to the other, right?
Okay.
Could you give examples of what a property of equality is? Could you show, like, give different names, like subtraction property of equality, multiplication property of equality, things like that, right? So those are things that you would want to think about. And remember, right now is not the time to write down that graphic organizer. I want you to go back after today, and that's the only real homework you have tonight, is to reflect on what we did today to submit those ideas, right? The whole point is that we're using that graphic organizer at home to reflect on what we've learned. Kyle's like, what is homework, Mr. Kenny? I don't do that thing. All right, looking here, last step, and I know that took way longer than I expected, but we'll be able to move through this one a little bit quicker. What should I do to 7x equals 42? First off, what do you used to do? Dividing by 7. But here's the thing, division is the inverse of multiplication. But what did we talk about in number 2? Not the inverse of multiplication, but the multiplicative inverse. So what should I do here to use the multiplicative inverse? Not divide by 7.
Multiply by 7.
Not multiply by 7. Not square root.
Multiply and divide.
Y'all, have you looked at number 2?
That what you did in number 2, you added and subtracted.
Reciprocal.
I use the reciprocal, the multiplicative inverse, which is 1 divided by 7.
And then you create.
And that's creating a 1. So I need you to remember, because this is going to help you in the future. So let me give you a quick example why this is important. 2/5 x equals 4. Alright? If you are only thinking about division as the inverse of multiplication, don't write this example down, but if you're only thinking about division, you're going to end up dividing by 2/5. Y'all want to do that?
No.
Same. It's easy enough. You multiply by the reciprocal. Or, from the very beginning, isn't that the multiplicative inverse, the reciprocal? And hey, what is 5 divided by 5?
10. No, I'm tweaking. I'm tweaking. My bad.
You're good. What's 2 divided by 2? So what am I left with? 1 times 1 times x is 1x, or just x. Use my properties of equality so it doesn't change. What's 4 times 5? 20. 20 divided by 2?
10.
Done. And that's easier to plug into the calculator. That's so much easier than trying to divide by 2/5. Can we all agree on that?
Yes.
So this is why I want you to think about that multiplicative inverse.
So we gotta use that if equation.
No, you don't.
Oh, let me write it
But
down.
I want you to practice it so that when you get to an example like this, it's easier. Similar thing, even if it was 1/3 x equals 9, do you want to divide by 1/3?
No, you do 3 over 1.
What am I going to do with 3? And first off, 3 over 1?
3 divided by 1.
There you go, thank you. And what am I going to do with that 3 divided by 1?
Times it.
Multiply.
Oh, so I'm multiplying by its reciprocal?
Yeah,
I'm using the multiplicative inverse?
you are.
So understanding the multiplicative inverse is going to help you long term. Does that make sense? I'm not trying to make your life harder, I'm trying to make it long term easier. I know you're used to just saying divided by 7, but if you're used